Next rule is a product rule. It allows us to differentiate a situation where we have two functions of x multiplied together. Right, so u and v are both representing a function of x. There's the formal definition for it. Of course, I remember it this way. Write down the first and diff the second, plus write down the second and diff the first. The faster you say it, the more fun it is. Write down the first and diff the second, plus write down the second and diff the first. Why do I remember it that way? Because I do it as I say it. It's telling me exactly what to do. Show you what I mean. Yes, of course I could expand this out. It's a bit hard to give examples right now because the only thing we know how to differentiate are polynomials. But as we go through more functions, these rules become more and more useful. But here's two functions. We've got x to the power of 7 times x to the power of 9 minus 6. So the rule says, write down the first. Oh, well, the first function is x to the power of 7. And diff the second. Well, the second function is x to the power of 9 minus 6. If I differentiate that, I get 9x to the power of 8. Plus, write down the second. Oh, that was x to the 9 minus 6. Diff the first. Well, if I differentiate x to the power of 7, I get 7x to the power of 6. Tidying that up, we end up with our derivative. Now, reality for a function like this, it probably would be quicker just to expand out and differentiate. But as I say, for the sake of an example, I can only use polynomials at the moment. So x minus 2, 2x minus 3. Mind you, you might not want to expand it out. Write down the first, x minus 2. Diff the second, 2. Plus, write down the second, 2x minus 3. Diff the first, 1. Still got to do some expanding, but at least it's not one of those big by huge. Yeah, I know, they're not that big. Alright, so I get 2x minus 4 plus 2x minus 3. There's my derivative, 4x minus 7. So differentiate this product. Write down the first, diff the second, plus write down the second, diff the first. So write down the first, x to the 7 minus x cubed. Diff the second, 6x. Write down the second, 3x squared plus 7. Diff the first, 7x to the 6 minus 3x squared. Expand out, collect like terms. That would be an example of where it would be ridiculous to use the product rule when you think about it. Because what was I trying to avoid? I was trying to avoid expanding out this expression. Well, I ended up having to expand out a very similar expression anyway. So, you know. Here it's probably useful because I don't want to expand this whole thing out. Okay, this is fun because we get to use both rules. Yes, I know. Hang on to your seats. Here we go. Write down the first, 3x. Diff the second. Hang on, the second is x squared plus 4 to the power of 5. In order to diff that, anarchy. Bring down the power, 5. Lower the power, 4. Diff the inside, 2x. Plus, write down the second, x squared plus 4 to the power of 5. Diff the first, 3. Whew. Now, let's tidy this up. I've got 3x times 5 times 2x, which is 30x squared. It's probably good enough for an answer, but again, it depends what we're going to do with it. So I'm going to factorise this. I've got common factors there. Common factor of 3. But there's also, for some reason, I chose not to take out the common factor of 3. Don't know why. But I do have a common factor of x squared plus 4 to the power of 4. Remember, it's always the smaller power when you're factorising. So I'm left with 30x squared plus 3 lots of x squared plus 4. Tidying that up, 33x. That's when I notice, oh, by the way, there's a factor of 3. Should have done it at the start. But there's my derivative. Okay, 2x times the square root of 2x minus 1. Well, that's 2x minus 1 to the half. I've got two functions. I've got 2x times 2x minus 1 to the power of half. Product rule. Write down the first, 2x. Diff the second. In order to differentiate the second one, I'm going to have to use the chain rule. Bring down the power, a half. Lower the power, minus a half. Diff the inside, 2. Plus, write down the second, 2x minus 1 to the half. Diff the first, 2. The mistake that's often made with ones like these, because there's so much going on in just the first bit, they write down the first, diff the second, a lot of people stop there and go, oh, well, I've done my work. But don't forget, write down the second, diff the first. Let's tidy this up. 2x times a half times 2. 2x. We have common factors. 2 is in both. 2x minus 1 to the power of, which one do we factorise out? I've got minus a half, I've got plus a half. Which one? Why? Exactly. It doesn't matter that we change from positives to negatives, you still take out the smaller. So I take out minus a half as well as the 2. I'm left with x plus 2x minus 1. Okay. Mere mortals have probably given up by now. Super mathematicians are going, there's still more to do. Look at that. 2 outside of 3x minus 1 on the square of 2x, square root of 2x minus 1. That is our product rule.